Security, commonly accessible methods of analysis, and traffic spoofing of the GSM standard traffic. And also will share with you experience of spoofing this traffic. GSM is a telecommunication standard, global mobile telecommunication networks. It's not really popular, but it's more developed and more common in different areas. More than 80% of territories, global territories, are covered somehow by GSM telecommunication. Also, number of GSM users is more than 4 billion. It's more than half global population, but let's speak about its deficiencies and about security deficiencies thereof. And the main problems with security of it. I made 3 examples which are the most vulnerable one. One-side authentication, unreliable coding, and vulnerability from the site SS7 network. One-side authentication, what does it mean? It means that mobile phone, in order to use telecom services, it has to authentify itself in a network to convince the network that it's him. But in a reverse direction, it doesn't work. The network should not identify itself in order for the mobile phone and mobile equipment to get connected to the network. It gives a possibility to do attacks like fake BTS attacks, files base stations attack. Fraudster can look as a base station, pose himself as a base station, so the mobile user's equipment gets connected to this base station, and it happens that criminal becomes some kind of a mediator between a mobile device and telecom operator, and he can control your traffic, calls, SMS messages, and internet traffic. Unreliable coding. The coding algorithms used in GSM standards and its differences, A51, A52, A3, they were developed in the beginning of the 90s when GSM had its first commercial realization network on the GSM standard. And since then, it has not been improving its encryption. And for a long period of time, 5.1 was considered a non-breakable algorithm of encryption. However, in the year 2007, to common access, an experiment was provided where they have shown that it's very possible, and right now in the common access you can find how it can be broken, even utilities to break it. And it all became possible. So operators make no attempts to somehow fix it. And of course, vulnerabilities from SS7 networks attacks. It's a general signalization channel. It's a system, alarm system for realization of alarming messages, network communications in phone networks. Well, the fact is that a fraudster can get connected to this network and use its possibilities for various types of attacks. For example, he can learn where the user is located. He can learn about his ID numbers, identification numbers are EMC or MC. MC is a unique number of the user, unique number of your SIM card. All this makes it possible to sniff your private data through the GSM channel. So I've shown you possibilities, 4 categories of how it is possible to intercept traffic. The first one, traffic interception on the level of mobile device. It's the cheapest one. It's the most common way of traffic interception when you install specialized software on your mobile phone, and afterward this software can easily be recording everything that you put from the keyboard, records your calls and SMS messages. Passive interception. Down here, traffic is intercepted without any changes. So no interrelation with transmission and receiving devices is not happening. So attacks of these types are the most difficult to identify that they did happen. If you want to protect from these attacks, well, you can protect by good encryption. Active interception with base stations. From passive, it's different, that there's an influence on the interface of communication between receiving and transmitting devices. So the same PBTS, the fraudster is a base station, and he can receive all necessary information that he needs. Interception level telecom operators. Telecom operator has all the possibilities to look after the user, to record his conversations, his messages, etc. While in many countries, including Russia, law enforcement agencies, they install special equipment on the side of the operator in order to improve the security, of course. In order to realize traffic interception, it is possible to use open projects, which you can find in the internet, and there are several of them. It's not one, it's not two, and I've listed only three, the most popular ones, the most developed ones. AirProbe. It's a project which realizes standard GSM standard interface, and with the help of this project one can realize traffic interception on one channel, RFCM channel, and use software defined radio equipped as SDR for transceiver, as a transceiver. OpenBTS is one of the biggest projects which also follows the topic of creating a possibility of creating open telecom operator with the help of the same software-defined radio devices. They want to create a telecom operator, and many countries which have difficulties in creating telecom operators, they use it and have successfully deployed this particular system. And Osmocom BB. It's also an open project, open source project. It's more directed at studying GSM standards, studying security issues, and discovering the problems in this particular standard. Equipment which is used for all these projects is not outside of, it's not in the fantasy price-wise or difficulty-wise. As you can see it from this spreadsheet, in order to do the data interception in the GSM standard, you don't need any super expensive equipment. It's enough to buy a TV tuner for about $20, which has a chip which supports GSM 900 and 1800 standards, and with the help of the software, which also can be found in an open access, you can make a small lab for interception, but you have to remember that it's illegal. The most expensive models are different from the cheapest models by the fact that they have higher range of frequencies. They allow you to do hopping, and hopping is a pseudo-random frequency switches. The fact is that if you really want to improve the telecommunication quality and remove the flickering, in the GSM standard they use frequency switches, and it makes it difficult to intercept the GSM traffic. So if you will use the same non-expensive TV tuner, you will not be able to record conversations due to the hopping reason. However, this also is possible to do if you will buy several of those TV tuners, and you will solve the problem of syncing between them, and then you will dump all the frequencies simultaneously, and then you will have the possibility of a full-scale interceptor. So I've made an experiment in order to make sure that this is really possible. For this, I've purchased Motorola C117 mobile phone. Why this one? The fact is that I was using Osmocom BB project as a basis. and it proposes firmware for the mobile phones in order to make them in a certain GSM sniffer. So the mobile phone has been reloaded with a new software, and a computer with a certain cable can patch the packages that he sees in the radio channel, sniff the packages. So the cable for connection to the computer, the server itself with the software, and a tagged mobile phone. Also, for the simplicity of this experiment, I took cable, PCSC cable. It's a cable that gives you a possibility to read the data from the SIM card. So the experiment itself. The experiment consisted of the following things. First of all, you take the mobile phone, which has to be attacked. It's been registered in telecom operator, and then you take it away with a battery. Because it already has been authenticated in the network, it has received TMC. It's the ID number for the mobile phone, but only temporary one, which is given by the network in order for the MC not to be transferred openly, the identification number. Also, during the authentication, KC is being transferred as a key through which the encryption is happening, the encryption of the traffic is being happening. So I have removed the battery so that mobile phone wouldn't be able to send a message that it has disconnected, so that operator for the next time didn't change TMC or the KC. Then I have connected to the PCSC cable SIM card, have read TMC from it, has read KC number from it. Then I have switched on the phone on a server with the software from Osmocom BB, and I started looking for radio channel and started searching for TMC that was taken from this SIM card. So the next step, I made a call to the input of the Osmocom program. I have sent KC, TMC, and I've started dumping files. And they have been decoded afterwards, and you would be able to see the SMS messages in plain text. And in the case of call, if you select a proper TMR code, you could be able to listen to recorded conversations. In principle, that's all I wanted to tell you. Thank you very much for your attention. If you have any questions, I will readily answer them. I don't hear the question. It's not in the microphone. Everything that you just told us, I've heard from many presenters previously. Well, did you do the reversing yourself? Yes, I did it all myself. And I've shared it with you. Well, simple as that. More questions? Well, thank you very much for your attention.